Welcome to the Defining Devices tutorial.
Here we are, just logged into our NeDi system and want to go ahead with the first discovery. After you've set the necessary SNMP communities, in my case I only need public, well, we can add private just for the heck of it, and the CLI logins, you can start discovering a network. I'm using this CIDR notation to discover a bunch of devices here in my network. As soon as you click start, a new tab will open showing you all the gory details of the discovery, but you can go back here and just watch. If you want, you can go back here to follow the discovery, double click in here. The page will scroll down as you follow the progress of the discovery. Now it's done. We can close this window again. Behold whatever has been discovered, or go back to the device list and show all the devices that have been discovered. But oh, what is that? When you see a hyphen as a device type, that means NeDi probably did not recognize this device. How do we solve this? Well, first of all, you can add the sysobject ID column here to see what we're dealing with. The sysobject ID is an SNMP identifier, which should be unique to every device type. So when you have the sysobject IDs here, you can click on one to go to other defet, which is the definition editor. This is helpful if you have several of those unknown devices, so you can easily determine which exact definitions you need to edit. Usually, if you have a single device like that, you'd go into the device status and click on this triangle to go to the definition editor. Now, if a definition does not exist, you will see this blue stuff here. This is the description, which can be also displayed by clicking on this eye. It will pop up the description with an SNMP get from this device. I know the device series from the description here, but if I was to find out the exact model, we can Google it. So now you can do your own research to find the exact model. Now, once we have that, we can select one of the models here from the same vendor that should be close enough. So let's see, we have a 2960 24 port model, so we could use probably that one. And it will copy the sysobject ID definition file from the other model to this one. Now all we need to do is replace this string with the one I have for my model. And if we're lucky, that should be it. This device is properly defined. And if this is the case, we can rediscover it here. We should not have a hyphen for the type anymore, and we should have a lot more information from this device because NeDi knows how to deal with it now. If you go back to the definition editor, if you have an accurate definition of a device and you want to send it to me, click on this mail icon, and usually your Outlook email client will open with the definition inside, and you can email it to me and I will include it in the next release. Now, what happens if you're not that lucky? So let's have a look at the fields that are involved here. So the sysobject ID will be used as file name and usually defines a device type appropriately. But for some devices, it doesn't apply, like stacks, for example. Sometimes you get a stack ID and then you need to determine the exact type from another SNMP OID, which would be this one. This should return the type. If you don't need that, you can enter a fixed or static type like this, and this type will be added down here as the type itself. An important part is the icon. So we can open the icon browser like that. So we see a bunch of classes like cloud, computer, firewall, load balancer, phone, printer, router in different sizes, a layer 2 switch, different sizes, being that one usually you'd take for a 48 port, 24 port, and less, like 10 or 12 ports or something like that. Layer 3 switches, sensors, fabric switches. This might as well be a Nexus switch or a fiber channel switch. Stacks, as I said, some sysobject IDs refer to a stackable switch and are not the exact model number. Then you could use an icon like that. Modular switches, switches with typically slots and line cards in it. Then we do have storage devices, UPS devices, video cameras, video conference systems. Usually they don't speak SNMP, so this is more appropriate for devices showing up via LDP or CDP or something like that. Wireless access points, wireless bridges, and wireless controllers. Those two, again, usually don't support SNMP. I know there is models that do, but usually you will only see those via a wireless controller or via LDP as a neighbor of a switch. So, once you're happy with your icon, it will be put in here. The size of a device is the height in rack units. So this is a regular layer 2 1U switch, which has a height of 1. The operating system is important to determine the way how to access its CLI. So there's a bunch of operating systems you can choose. The SNMP version determines, of course, the version that you want to use for that device, but also if the device supports 64-bit counters or high octet counters, or only 32-bit counters, in which case you only select the V2 option here. There is old routers that need both, so they have Ethernet interfaces and slow serial interfaces, which can only be read by 32-bit counters. In that case, you need to select MC. The third option is HS, which means it does support 64-bit counters, but the speed needs to be read with 32-bit OIDs. It's a weird case, so if your device does not indicate the speed properly, you might want to resort to that option. If you see a walking guy like this means you can actually perform a test walk. In this case, I did walk the 32-bit counters. As you can see, I get a result back. And the second one here is the 64-bit counters. And in that case, I also get a result back, meaning this switch does support 64-bit counters indeed. So it's safe to use high octet counters for this device. Now, another interesting bit here is the uptime. The uptime counter is a 32-bit counter counting time ticks, or a hundredths of a second. Now, the problem with that is it will overflow every 1.3 years. This is really bad because in most of the cases, we really need to know how long a device has been up for. Now, in this case, we can use the SNMP engine time if we do get an answer. And in this case, we actually do. So this is counting the seconds. And the advantage is it will overflow every 130 years, which should be fine for most of us. So if supported, you can choose SNMP engine time. I have observed on some devices that at some point SNMP engine time will not increase anymore, even start to decrease its value, which doesn't make any sense at all. I don't know what Cyxel was thinking, but well, that's what I've observed. MAC address table. So most switches support the normal MAC address table, which is this guy here. You can walk it. It's the bridge forward table. And it will return something like this. This is the MAC address as a decimal number. And this is the interface index where this MAC address was found on. Now, you can use that one to check whether this returned index matches the interface index, which would be the case if those two numbers would be the same, but on our Cisco switch, it's not. So you can see that the actual interface index is that one, and that's the bridge forward index. But Cisco is a bit different anyways, because it uses something called VLAN community indexing, which is down here. That's only applicable for Cisco devices, what I've seen so far. That's why I also support reading the MAC address table with SSH, which is much faster than this VLAN community indexing approach Cisco still pursues. I don't know why. Now, for other switches, and for that case, let's head over, or let's go back to our device list. Let's pull up this ProCurve switch. Here we do have QBridge VLAN index. Why? Well, the second guy here, that's the actual QBridge index, which is much better than the normal bridge MIP. The QBridge includes the VLAN ID where this MAC address was found before the MAC address, here. But ProCurve decided to not use actual VLAN IDs here, but some sort of index for this VLAN. So I think things would be too easy, right? If you could just select QBridge. So some devices support QBridge, some devices index the interface index. ProCurve doesn't do that, which can be discerned here. So you see the interface index matches whatever the bridge MIP returns, but they decided to index the VLAN ID. So here you can determine, so 1 corresponds to VLAN 1, which is fine, but 2 corresponds to VLAN 163 and so forth. So yeah, things would be too easy, I guess, so they decided to make it more complicated. So it's not me. Right, so for ProCurve, I recommend you use VLAN index here. And for the rest, just play around with those things. You will see when you get errors back if it doesn't work properly, but those 4 walking buttons here should help to find the proper method to read the bridge forward table or the MAC address table. Now for wireless LAN controllers, there is a few more options here. So we have Aruba support, Aerohive, Cisco single APs. I don't think you see them anymore in the field. Cisco wireless controllers, they should be supported. Extreme Wing controllers are supported now to a certain extent. There is some support for Cisco Ruckus Smart Zone. The Zone Director should be supported rather well. And then we do have the open source DDWRT project, which is supported as well. Please note that for Microtic, you can use the normal version and it will derive the signal strength automatically because that's how they implemented it. And I just make sure that if I have a Microtic device, which can be set in the operating system, here, Microtic ROS, and then it will determine the signal strength automatically. There is certain devices that only support the bridge forward table via CLI. Moving on, we do have a field for the serial number. In this case, I'm simply reading the standard entity MIP, and the first module here is usually the main switch or the switch board or the chassis itself, which yields the serial number. The boot image, you can also get this value like that. This ProCurve switch does not really need a ARP table because it's a layer 2 switch. So we leave it at no. It will speed up the discovery or not necessarily slow it down. Let's put it that way. So the discovery protocol on the ProCurve switch is rather simple. It's straight LDP. And remember the mess we had with the VLAN indexing here or the interface indexing on the bridge table. Now for LDP, a lot of vendors decide to populate this LDP neighbor MIP not with the actual interface indexes as we see here. So 5 is an actual interface index and 1 would be the first neighbor on this interface. So on interface 6, we seem to have 2 neighbors, 6.1 and 6.2. 6.2 is only a MAC address. So that's another interesting new, how shall I say, world thing that neighbor devices don't report the actual name, but rather their chassis MAC address, which then I need to look up if I can find this MAC address somewhere else and then determine the actual neighbor name from that. NeDi can do this automatically, so usually you don't have to worry about it, but it's good to know that sometimes you get mixed results with LDP discoveries. The second value here lets you test if you need to do any interface mappings. So here you see 1 equals 1 and so forth, 4 equals 4. So that doesn't seem like there is a mapping necessary. In this case, we are using the X for interface description, or there is a third option here for the interface name, but ProCurve, for those switches at least, uses the actual index as interface name as well. Now let's jump back to our Cisco switch. Let's go back here. CDP, right. So CDP is actually past this separator. We can check out CDP. That's what we get back with CDP, and usually CDP works just, without any mingling. It is a standard, non-standard protocol, but at least it's consistent. So in that sense, it's a standard protocol, unlike LDP. Now let's see if this guy supports LDP. So either the iOS is too old or LDP is turned off. Let's go check out a newer Cisco switch like that one. Let's see what we get with this one. And here we see we have already LDP populated next to CDP. So if you have multiple discovery protocols supported on a device, like CDP and LDP, you can separate it with a pipe, which means it will search for CDP or LDP. And in this case here, we do have LDP XN. How do we get to that? Well, if we go have a look at LDP, we see neighbors. That's good. But now we see an index of 2 and then 742. I guess again, Cisco decided to make things a little bit more complicated than necessary. So we don't start with the first neighbor, but we start with 742 for some reason. But interesting is this number here, 257. Now let's have a look at this second walking guy or button. So we see 2 corresponds to Gigabit Ethernet 02. 5 corresponds to Gigabit Ethernet 5. So if we click the third walking button, we might be able to derive the actual interface name. And yes, indeed, 4 corresponds to Gigabit Ethernet 04. Right, so that makes sense. As you can see, and I'm showing this as well, I'm clicking here on the actual interface names. So this name would correspond to this interface index. So as you can see, it's 10,104 and not, as we saw here, simply 4 or 5 or whatever. So that's why we have to do all this. It's not me, trust me. I would have things much easier if I was to say anything, but I don't have a saying in this, obviously. So that's how you can determine what exact method you need to use here. So as we've seen before, LDP XN, and it will jump. When you click on this walk, it will change the field accordingly. But remember, we did have CDP as well. So that's the third non-standard button over here. There is more. There is Foundry Discovery Protocol, which obviously is supported by Foundry devices, but Foundry itself doesn't exist anymore. So whatever the current owner of Foundry is, if you still have those devices. There is also a method to use ubiquity neighboring protocols for wireless links. Now let's see what else we have here. So with the first 3 buttons, you can determine which LDP method would work best. And then we do have another button here to check whether we get neighbor IP addresses. This is interesting because we see here that's the IP4 neighbor management address. And then here we do have 16 and then a IPv6 address from this neighbor. So NeDi will not be able yet to use this IPv6 address for the discovery, but at least you know that this device announces an IPv6 management IP address. So I'm not going to write this definition because remember we did had CDP or LDPXN in here. I'm just showing you what are the possibilities here. Now, we can move on here. It doesn't matter. Some devices need a custom OID for the name. The name OID usually is a standard OID that is in the MIP2. But for some printers and weird devices, there is a custom OID for the name. Usually you don't have to bother with those two. Description is also a standard OID. VLAN names. For Cisco, we use this 9946 something, and it usually works well to get the VLAN names like this. Then there is a new option here to get VXLAN mappings. So the VN network ID for a certain VLAN would correspond to the VXLAN. So Cisco offers this MIP, and then for other devices I have a CLI method which don't support any SNMP method. So CLI can be used for Arista, for example. Sometimes the VLAN name requires a VLAN index. Yeah, I know, again, it's not me. I think if you look at all the available definitions here, I think Extreme does something like this. Extreme has this MIP to get the VLAN names and then requires an index to get to the actual VLAN ID. So for Extreme, you need something like this for it in order to work. Don't do this. I jump back here to my 2960 now. Don't do this if you don't need the VLAN index, just leave it empty. Now I noticed because of our messing around with the definition, group and mode are empty. So usually for Cisco devices, group and mode should be VTP group and VTP mode. Obviously it's not in here. So let's see, when we jump to this definition here, I'm going to open the other def we had before in a new tab by control clicking or middle click on this icon. So I have a new tab with my 2960 definition. And as you can see again, group and mode is empty. But here on this 3560 switch, we do have a group and mode OID. So I'm just going to copy this group OID and paste it here. Check it. And indeed, we do get a group value back, the home group. So let's do the same for the mode. And we should get the mode, and hopefully it's transparent, but yeah, it is transparent, which is a good thing, I guess. I'm not using BTP anyway, but I recommend if you do have Cisco switches, do the transparent mode and set a group. Configure a group based on the area your switch is in or something else, because the VTP group can be used. And I'm going to open the device report here, again in a new tab. And you can do a group distribution report like that. And as you can see here, we do have VTP groups now, which can be used to divide our network. We are at the 2960 switch again. We added group and mode. We have interesting fields here, config change and config write. What is this? Well, Cisco supports a timestamp of the uptime that we see here when the configuration has been changed. So if we check the value, that's the uptime, 20 days and 39 minutes into the switch being up, the config has been changed. The config write timestamp says when has the config been written to flash. 18 days and 13 hours, 37 minutes into the switch being up, the config has been written to flash, which means the latest version of the config has not been written to the flash. So the switch might boot up with a different config than you have set. So this enables NeDi to check whether a backup is necessary and can warn you that the config should be written to flash. But remember the uptime overflow here? Even if using SNMP engine time, those two counters might not work appropriately all the time. So if you get a lot of messages saying that the config has been changed since writing to flash, Try a write mem or a safe running startup and see if it disappears, or in the worst case, reboot the switch. Again, it's not me. I just don't know how else to mitigate problems like that. If you ever need to test a NoID and you're not sure if a NoID works, we have a new field here. It's a yellow field indicating that this is the test field. So you can either walk this OID like that, or let me copy this one again in here, get something and check whether you get a result. This field will not be stored in the definition, so you don't have to worry about it being populated when you write the definition. Here we do have the fan status, so we can check that as well. You need to investigate what would be appropriate values for the fan to be okay. So in this case, it's 1 and 5, meaning there is no fan on this index. It happens sometimes. So for Cisco devices, I recommend using 1 pipe 5 or 1 or 5, as in regular expression. So this is the system part, which probably is the most complicated part. Down here, we do have interfaces. Let me write this config now to make sure that we have all the important stuff saved. Interfaces, if you're not sure, you can remove whatever is here by clicking this X. You can add the first possible standard way of looking at indexes. There is a second one which basically uses a different OID for duplex. I think it's more on older devices that you might encounter this one. So the first button here should work most of the time. If you encounter a more exotic device with a lot of interfaces you don't want, you could limit the interface range here, limiting the SNMP walks to this index range that you specify here. Usually you don't need that though. As to the addresses, we didn't exactly look at the ARP stuff in too much detail, but you'll notice that there is old IPv4 and 6, or a combination of old and IPv4 and 6, or even the newer IPv6 MIB, and so forth. So it's always some sort of trial and error to find the correct way to get ARP entries where appropriate. For firewalls, certain firewalls don't support ARP via SNMP, God knows why. In this case, you can try CLI. Now, the addressing of the interfaces corresponds tightly to whatever ARP method you are finding out to use. So usually if you have ARP set to IPv4 and 6, the interface addresses should work just the same way. In addition to the addressing, you can also check the routing tables if you want to, and in that context you can check, or well, if you have it configured, you can verify whether VRF MIBs of those kinds are supported as well. As usual, you can use the walk buttons to check first what's working and then set it to a certain method, and then you will find out in the discovery whether this works or not. For the duplex here, we do have something like this. So full duplex, unknown, whatever. This is actually a numerical value coming back, and this is the numerical representation of this duplex value. It's 2 for a half duplex and 3 for a full duplex. If there is an indexing necessary, you can check this out. But in this case, this number equals the value. So it's both the same, meaning you don't need to walk a duplex index. In that case, you can remove this OID. So don't do any unnecessary walks. The rest is pretty much standard MIB2 stuff. Down here, we do have the pvid for the interfaces. Obviously, the standard pvid does not work. Let's have a peek on this other definition we still have open, the 3560. Down here, we do see pvid Let's copy this OID to overwrite this standard pivot and check it. And here it obviously works. So we have the correct pivots. In case you're wondering, 666 is an evil VLAN. Yes, it's indeed my DMC or the outside VLAN. So I put 666, so I know it's evil. For Cisco, I unfortunately still don't have a method to get the tagged VLANs reliably off the switch. To show you what I mean, let's jump back to our ProCurve switch, which is obviously a HP switch. Because here I do have a method, QBridgeCurrent, which allows me to read tagged VLAN information as well. This is a bit mask. It's something like this. So it's a bit mask in hex. And FF is obviously all bits set, meaning VLAN 1 is on all those ports and so forth. So it's not that simple to discern the actual tagged VLAN information from this bit mask, but it's possible and supported on a number of devices, and unfortunately not Cisco yet, because they do some automatic pruning and other stuff. So it's really hard to get this in an efficient way, and I'm still working on that, and hopefully I will come up with a solution eventually. For ProCurve switches and other supported devices in NeDi 2.1, you will see blue pivot fields when there is another VLAN tagged on this port. And if it's a pure access port, there is no blue color. But for this port, again, we have the DMC VLAN tagged on those links. Now, again, pivot index, only put it if necessary. Then on PoE switches, now we can put PoE load. For that, let's jump to the 3560. Should be in here, that one. It's a bit better to see what's new. PoE load, again, we do have the actual exact load in milliwatts, but also the allocated power. That's the power budget the switch reserves for those devices. So you see it's much higher, but it's important to be alerted if the switch overshoots its budget and starts to turn off devices, right? That's what you, in the end, that's what you want to know. Here we see the method that's being used to map interface indexes to the power Ethernet MIP values. So the last button here will show you the PoE admin status, meaning is PoE enabled on a port? And that's the actual interface information here. So for this Cisco switch, we see that it's port gigabit Ethernet 05, which is represented by 15 in this MIP. It's a bit weird for Cisco devices again here. So you have to put Cisco stack MIP. Let's go back to the ProCurve switch to show you what I mean. That's the ProCurve switch. Here we have IF index equals PEM index, right? So it's much easier because here this number corresponds to the interface index. Unlike the Cisco switch, where again, if you look at interface indexes, they're like 10,105. And if you look at this power Ethernet MIP, it's only 5. So we need a way again to map this index to the actual interface index. And for Cisco devices, there is a stack MIP option. Sometimes it's better to use the name and sort of guess the interface index. I'm doing this for Cisco 4500 modular switches. Yeah, sometimes it's not that easy, but usually it works with one of those methods. The easiest way is if the interface index matches the power Ethernet MIP. Again here, for the Cisco stack MIP, you need to get the actual stack OID, here you can see port 15 maps to interface index 10,105. Okay, that's pretty much interfaces. Moving on to the modules. Here we have a series of buttons again. Let me clear whatever we have in here. The first one is the entity MIP, a standard MIP2, which works for most modern switches. Sometimes you need to resort to enterprise-specific MIPs. But if the entity MIP works, then you have something like this. And you can always test the class OID, for example. And if this works, then you know the entity MIP is supported. I picked the class OID to show you how to actually get the modules classified properly. So I know from experience the entity MIP class 3 is a chassis. Then 9 is a module as in line card. 6 is a power supply. 8 is a sensor. 10 is a interface. And interestingly, 10,005 corresponds to, I think, gigabit Ethernet 5 and so forth. Yeah, so those are the most important classes. And for a switch like this, remember it's a 29, wait, which one? Yeah, that's a 3560 switch. This switch does not have line cards, no slots to plug in a line card, but only 2 SFP slots. And if you have SFP slots, the class value here that you want to get is an interface, right? Which is 10. So in this case, NeDi will be able, hopefully, to read SFPs from the switch and add it as a module. Obviously, my switch here, that's the 3560, does not have any modules here, so you don't see any SFPs. Now let's go have a look at my 2960-24. So we do have a module here. It's an SFP. NeDi was not able to read the power levels, but you can see at least we have one module for this 2960 switch. Let me jump in here again. So that's happening because we have a class value of 10, and then we do get some more info, like serial number as well, from the entity MIP. Let me pull this up here again. So you see here, that's, I think that's the SFP, and that's the serial number of the switch itself. Sometimes they do have a serial number of the main board, but usually this is not very interesting because it's not tracked or something like that. For Cisco switches, you can try to get the optics values like this. And if you see any values that are negative, that could be dB levels of a transceiver, in that case, you could use the Cisco method. All you need to know is the factor which is used for the unit, which is used for the actual power. I know for a fact that Arista, for example, so if this was an Arista switch, you could try microwatts to get the correct power levels of SFP. It's a bit trial and error. Set it to something, read it. If it makes sense, if you compare it to CLI show commands, and if it makes sense, keep it. If not, try to adjust whatever you have here until it makes sense. So this is the modules for the most part. There is some interesting look at the device list. Let's pull up. Yeah, let's take that one, for example. So here we do have more interesting stuff what modules is concerned. As you can see here, I have Cisco SFPs. dBm divided by 10 would be the proper value for our Cisco optics power levels. The rest is pretty much the same. Down here we have an additional status field populated, and the module status is interesting as well. So you can get the status of power supplies and line cards. And for Cisco, a value of 2 would mean it's okay. This can also be a regular expression if you have more than one okay value, as we've seen for the fans here. Now, I'm going back to our 3560 switch because here we do have some more interesting values that can be used in the graphs. And those are the system values like CPU load, which we can test. Starting with NeDi 2.0, you can also add a factor of -%. That is, if you only have an OID returning unused CPU percentage. This can be happening on a Linux-based device, for example, where you get the CPU free time or something like that. Usually you can leave this empty because most devices do actually report the value. Sometimes they report like 10 times the value. With that, they have like more accuracy. But yeah, if it's 1, you can leave it empty. You can specify a default threshold. But if this is empty, we just use 75% as a default. It can be later changed in the device list to match whatever your actual devices are going through. Memory free. Here also, if it's the return value in kilobytes, leave it empty. If it's in bytes, you can add a multiplier of 1024. If it's in percent, you can add a percent sign. If it's relative used memory, instead put -%. So NeDi will always report the available memory or the free memory. The threshold here is 1 megabyte by default. You can increase it or put a percentage. If you have percent here, you might want to put, I don't know, 10% perhaps, rather than 1 megabyte. If you have a device discovered and then later change the definition to be using percent, you will have the wrong default threshold in the device list. In that case, you need to go to the device list, select the devices in question. I'm just going to select that for now. And then you can edit the proper threshold here for the devices that have been discovered already. So that's because the thresholds for a device, they will be set the first time a device is discovered, and those thresholds will be used in the devices table. Moving on to the temperature, sometimes temperature again is multiplied by 10 or by 2 in order to get more accuracy after the comma. We are only using integer here, so we will just round it. And if necessary, put a multiplier again here. Put a threshold. Default is 75 degrees. If you want a different threshold for certain devices, you can put it here. And then last but not least, we do have, for older Cisco devices, the mem.io value here as a custom value. The syntax here is custom label, so mem.io. Whether the graph is a counter or a gauge, so put semicolon C or G. And then the unit, which is bytes here, but it can be anything else. I mean, depending on what value you want to monitor for your device. An interesting one for firewalls is number of VPN tunnels or something like that. Or for a VPN concentrator, it's number of sessions. Or for a wireless controller, it could be number of registered access points and so forth. Here, the OID is put and then a threshold. And because this is actually mem.io, meaning bytes free, the threshold here is negative. Once you're done with defining the device, you can click update again to be sure you have the latest changes in your text box here. And then you click write to write this definition. If you want to edit some values here by hand or adjust something, you can do this by typing in here. As soon as you unfocus this box, you get a green border around it, meaning that you are in direct edit mode now and you cannot enter anything here anymore because you've edited this text box already. Nevertheless, you can write the definition now, either email it to me as I said, or then start a direct discover here. And then behold, that new device that should be properly supported now.